Welcome to the Stewart Squared podcast. We're going to do another session, and right now we're going to repost on Twitter your dad's account so that people can listen to what we're about to talk about, which should be really interesting because I have been vibe engineering all day, and now this is my first, what do you call it? My first ESP32, which is a knockoff of the Arduino, and I just got it up today, but there was an error. But really excited to actually build physical things. And I mean, like, is it crazy for you to see this, and see this kind of like machine? Because this used to represent like a giant room in the 1980s, right? Doing something like this.
So I just reposted our stream. Don't know if that worked, but so let's talk about that because you're a vibe coder and you're trying to do hardware, and I don't think anybody's actually claimed that you can vibe code hardware yet.
No.
So
right at the edge.
Yeah. So why are you into Arduino and ESP32, whatever it is?
Yeah. So I got my Raspberry Pi already set up, and I'm going to connect my Arduino to my Raspberry Pi to do something. I don't even know what that is yet. But why am I doing it? Well, because part of me, I just want to build interesting things and have more intimacy with reality. And I think we've discussed on this conversation before. Like if you build hardware, you build physical things, that teaches you about how reality works. So part of me wants to do that. Part of me wants to just see how far I can go, see how far I can take this fact that I have a private tutor who can take me through each step of the way. And it was really beautiful this morning when I had to download Arduino IDE, the integrated developer environment, which is like
Development
cursor
environment.
but it's
Yes, I know.
yeah, but it's specific for Arduinos. Like there's a specific Arduino one, and ESP knocked off Arduino, but then you can still use that Arduino because it's a open source. My friend said that Arduino lost because of the tool chain. So they've lost because they couldn't figure out the tool chain, and ESP built a better tool chain. So we could talk about what a tool chain is. But yeah, so, and the other thing is just like all the fear related to AI right now. A lot of people are, particularly programmers, are like, oh man, I don't know if my job's going to be around in 3 years with how good the technology is at building software. So part of me is like, okay, well, maybe it's a job security if I just kind of go and build physical things.
Which is probably true because then you kind of, the other meme, I guess, in the AI world is robots. And, robots are a big deal. And so as we've talked about before, this is sort of physical AI. And you got AI with LLMs and text-based prompting that produces remarkable results, but at some level, it's a little bit of a shell game. The idea that you can control hardware and have the hardware be intelligent and autonomous is sort of the next thing. So X1 just introduced the Neo robot, which is getting, it's kind of like, oh, this is cool. We can have a robot in my home and it'll fold my shirts and make my coffee. But if you look at the reviews, it's like there's a guy in the other room controlling the robot. And it's like, oh, so you get to spend $20,000 to buy this robot and you're going to have somebody living in your house or controlling it in order to train the robot for future buyers. It's like, doesn't sound like a great deal to me. And that's kind of the bottom line out of the reviews, at least. And so when you kind of try to figure out when is physical AI really going to matter, it's so far out there that it might not even be my lifetime. Depending on how long it lasts.
Because the real world is so complex, and it's like software is this constrained thing that is like it's fantasy of human, co-creation. We all agreed on these standards, but it's pretty, simple compared to the complex real world, right?
Yeah. The interacting with the real world is, I think about our house. If we had a robot here, would it ever get to the second floor or to the basement? Like just walk up and down stairs, or does it have to take the elevator, which we happen to have? But and then when you walk outside and I've begun to see robots, street robots. I saw them in LA when I was there. I think I saw one in New York. Well, those are not so much LA, but those are urban areas where you have sidewalks and handicap, transitions between the sidewalk and the street. And, so there's you don't have to have a robot that can step up and down. So you have rolling robots that do delivery and stuff like that. And that's a constrained use case. And you kind of pull that off, although I can't totally figure out why I'd want to order through a robot anyway. But out where we are, it's a dirt road coming up here, and there's no way a robot's going to make it to our house, much less a delivery driver. And we do have dashing delivery and DoorDash here. And so we don't take the risk of getting takeout or delivery orders. So it's you start going down the path here and go so when does it get to the point where enough people can actually use it that you find out whether, and that's just delivery, and then you have AVs like Waymo and Zoox, and that's really complicated, but at least they're on a road, road paved, and there's kind of rules, not very stiff ones, but so the idea of using AI with a physical thing is a huge stretch, and
But there's two distinctions, and I've been thinking about it a lot recently, is that what do you mean by do a physical thing? Because today to get this guy running with my computer, I downloaded Arduino IDE. I got all the libraries and the packages all set up. I got it to write the code for me that it would turn it on. I ended up hitting an error and have not had time to go back and actually figure out what happened. Which is a very common thing. So there's two aspects. There's one, me as the embodied agent who goes and interacts with this technology and goes and do things and has the AI both teach me and tell me what to do. Teaching is great. Teaching is 100%. If I want to learn what package I need for Arduino and why I need it, that thing is great. Doing it is not that great. It's good. It's really good, but it's not great. And the coding agents are pretty good. They're getting pretty good. They're getting to the point of great. I don't every part of the software that the hardware has in it is going to be dominated by these agentic machines. But then to actually have some sort of robot go and do things like you're discussing, that feels very far away. You showed me the Unitree robot that your friend had, and it's just a gimmick. There's nothing. It's a funny gimmick, but it's just a gimmick.
There's no autonomy. Autonomous there. Nothing autonomous. You got it fake autonomy by training it to do certain things, but you still need the remote control to tell it what to do. So you're trying to teach yourself hardware and to understand it. In terms of us being parallel, I'm not a programmer. Never learned how to program, although I tried back in high school. I think I learned enough to know how programming is done, but not how to do it myself.
Yep.
And then I learned about hardware because I started in the PC industry, and I had to learn about microprocessors and BIOS, basic input-out system.
What is that?
So in a PC, in an IBM PC and derivative, there's a standard component called a BIOS, which is matched up with the operating system, Windows. Or originally MS-DOS. And it's the part that defines the standard interface so that somebody else can build a computer and put a BIOS in there, and then all the software will work on it, as long as it's compatible with the operating system. And but knowing kind of how microprocessor design and how the interface is between the software and the hardware and all that inner stuff, I learned enough about it to at least fake it.
So I'm pulling up the Arduino IDE right now.
All right.
And so there's a bunch of code here. I didn't write this code. This is just a test. And the HealthTech is the name of the thing I've got. So it's there's all these things that I need to learn and I'll share Cursor as the other explanation, because Cursor is an IDE, but why do I need a different IDE for Arduino than I do for writing software on my computer? Like, what's going on there? Why do I need a different IDE in the BIOS? I'm wondering where in this is the BIOS. Is the BIOS on the actual Arduino itself?
It's in firmware.
In firmware, okay.
Yeah, so it's in a storage mechanism that's not part of the chip. Now, that may have changed over time, and
Interesting.
that input output thing might be embedded in the chip itself at this point.
Interesting.
This is where I haven't totally kept up. But the BIOS might be a concept that was relevant when you had the IBM PC and MS-DOS, and it might not be relevant in a system like the Macintosh.
Is that what people mean by system on a chip?
No.
Like some of those things are coming in? Yeah.
It's a system on the chip. You take all the components, and there might be firmware for the input output system. But it's a more generic, that's a superset, if you will. And it goes back to, we just had this conversation last week, I think, about like, where does the software end and where's the hardware end? What's the difference? It's all very mysterious because at some level, even hardware is software.
Wait, say that again. Why?
Because you're designing a system that can process ones and zeros. That's really controlled by software, even though it's in the chip. And so there's embedded systems,
Embedded
operating system. And so there's like,
it's an embedded system.
It's embedded in the chip. It's embedded either in the computer system or in the chip itself.
So, and you've loved cars your entire life. And as we've kind of both grown older, basically, you've noticed the computers are merging with the cars, which we've talked about for probably a decade or so, of like Apple trying to do that, and Apple creating their own car and all these different things, which is really interesting. But there's a mechanical thing that you grew up with that is now merging with the computer. Have you learned anything about that? What are your thoughts on that?
So, Valerie, my wife, bought a Rivian, and a Rivian is designed ground up to be an electric vehicle. If you start from ground zero and you build a new car and it's electric, and it's run by computers, right? So that it is a computer in the same way that an iPhone is a computer. And it doesn't look like a computer is a computer, and there's a range of definitions of computer, but you have to have an operating system, and you have to have a way to control all the other pieces of the computer. So the Rivian is actually a computer on four wheels. The Tesla is too, but they were first in market, and so they're actually lagging a bit. Rivian has started with that, and BYD and Chinese manufacturers have really started over again. So if you just do a de novo design of an electric vehicle and you kind of understand all the different components, it ends up being a computer. It just happens to have four wheels and a steering wheel. If you go into that, like it did with the iPhone, and this wasn't apparent right away with the iPhone, but the phone is just an app on the phone. There's still a physical component because you have to make the call and connect to the network.
Oh, interesting.
So when you're using an iPhone or an Android device, you're using the phone as an app in that system. And there's a bunch of other apps. And so maybe you don't use the phone very much. In fact, that's part of what's happened is people aren't really totally into just calling people anymore. Because you got a computer and it can defend you against random things. So conceptually, cars are becoming a computer system. So where the computer is the primary design portion, and you build everything else around it, as opposed to building the car and then sticking a computer in it.
So, have you seen the meme of Trump in the Tesla where he says everything is computer?
Mm-hmm.
Yeah. So that it's funny because that's true. Like everything is
fundamentally true. And to the degree that, there's some sign of intelligence in the Trump brain, he identified correctly, yeah, this is a computer, even though he said it like everything is computer, like he can't speak English. But And I get that sense. So, just as a little aside, Rivian's been increasing the autonomy in its electric vehicle. And it is now to the point where when you're on a highway and it has the data about that highway, um, it actually tells you to take your hands off the steering wheel. And you just go along and you're not actually got your hands on the steering wheel. It's keeping track of your eyes. So it wants to know that you're looking forward. If you look to the side, it'll start sending off alarms that you're not looking at the road. But on the roadmap, and I just listened to an interview with R.J. Scaringe, the founder, they're actually going to go to the next level of autonomy, which is you just tell it where you want to go and it takes you there. So this is a really, really fascinating thing because it's the precursor to whether humanoid or other forms of robots that have to operate in an environment that's messy and, bad weather, stuff like that. Icy roads. I mean, how does a car deal with icy roads if you're like not driving it? Anyway, the issues are tremendous and never ending because it's going to be like decades before they figure this out. And maybe at some point you get to the point where everybody has an AV and they talk to each other. So you don't need to drive them.
So there's one question about IT. We've talked about how Apple has probably the best IT in the world, and what's his name, the CEO Tim Cook can go in and know what's going on in any level of the company, of like components and all these things. It's all in IT. It's all registered. Everything's in the computer. And so it makes me think of like, well, that's just going to increase. And like our world that we both existed in the 90s of like, okay, well, you have this phone. Sometimes you got a mobile phone. It's really big, but there are computers running in the energy systems and everything like that in the back in the offices and everything like that. But they're not a part of our everyday life. And now it feels like everyday life is just going to become the computer. And where does that go as a society and as a species?
So this is why I think the critical thing for technology is real time. Everything has to be in real time. And so there's a difference between synchronous and asynchronous, which I think I talked about in the previous episode. The world has been asynchronous as long as computers have been around, and it's still only partially synchronous. But, I used the example of Facebook's newsfeed that it could update a newsfeed across 2 billion users, but only updating the right ones. That's a very difficult real-time application. And so there's real-time elements, but what you're talking about is when the whole thing becomes real-time, right? There's no longer any concept of batch systems and everything is done in real time. And so the whole computing system has to understand what's going on in real time, where you are physically. So there's sort of outer edge applications where Niantic has done this, but there are others working on modeling the whole world, knowing where the building is, right? And keeping it up to date so that if a building gets torn down and replaced with something else, that's in real time that happens. That updates the whole system. And you start thinking about stuff like that, and that's really, really interesting. And that's why I'm so focused on, LLMs are a huge batch system, and they're always out of date because the date that you commit and publish the LLM, you're not updating it anymore. Well, it's beginning to change, but it's still done by exception rather than as the rule. So it's what we're headed for. Well, the whole point of everything that's going on now is to make a real-time system that learns like our brain. We talked about that before too, that, that it can understand input and put it into context and develop a new understanding of the physical world and the virtual world so that everything is happening in real time. It is the thing that is the outer edge of everything the tech business is working on.
So I've got something really interesting I'm going to share on my screen. I'm going to introduce, we've probably shown you the agentic systems here, but I've got Codex open, and Codex is really interesting because you talked about batch processing and synchronous and asynchronous, and I'm just going to do something to show you what it does. Make this better. So this is a Three.js demo that it took me 5 minutes to code earlier today. And I wonder if I can, I can turn it on here. And we'll see the difference. I just told it to make something better. And this is what it made. I didn't give it any instruction, but this is what it made to show off how Built with Love by Codex, just like a 3D model of the solar system with various things. And so now it's making that better. That's funny. It actually asked for you decide. It asked for me to give it more information because it didn't want to make a decision, which is not normal. That's not normal. So the reason I'm showing you this is because this is taking time. This is not an immediate thing. And I don't think this will ever be immediate. I mean, maybe you have a lot of faith in how fast this thing can get, because how much data processing, how many the big data centers can they build to make this immediate? Do you think that's going to happen?
Yes.
Yeah, interesting.
Totally. I believe that is an article of faith in the way I look at the world.
Yeah, interesting.
So the most interesting part of this is getting on so many airplanes, because I just spent 2 weeks traveling in 6 flights or whatever.
Yeah.
One of the flights had really crappy Wi-Fi on it, but all of the flights had marginal Wi-Fi on them. And if you try to use Wi-Fi on an airplane, you find out why it's not real time, right? Because you lose the signal, the signal's weak, and it's just not working. So in a world where that's still true, then is it making it better? Is that what it's doing?
Yeah. Well, and it's fun to share this while you're talking about it, because this is like, I don't expect this to get, maybe, I mean, you're kind of convincing me though that maybe this will, and there's questions, but keep on going about the Wi-Fi. You're going to say Wi-Fi.
So you have to have a network that's always available and always high performant. And I wrote a little Substack about this because Valerie and I went camping in a place where there's no cell service, and we're using our Starlink. And I could do, while we were driving, I could get on the internet and operate at speed, just like I do here, because RAS is Starlink as well.
Yep.
And so that gives you an idea of the future, where you have high bandwidth, synchronous internet access everywhere, right? And they're putting Starlink on United Airlines flights, and I'm a little pissed off that I haven't been on one of those airplanes yet. They've installed it in like 50 or 60 airplanes, particularly because that was a United flight where the Wi-Fi was so bad that it was unusable. And so that's just one condition, right? So you try to think of anywhere that you might want to be and what level of internet connection you have and how performant your device is, and all of the different elements of this. And a lot of people object to this idea that, but you can bury your head. But I believe that this is the fundamental driver of all future technology and how it's going to affect society. It's the Evernet, which we came up with 10 years ago. And but having an Evernet that actually works everywhere all the time, regardless of where you are or what device you're using, makes the whole thing real time. So by then they have to solve the problem of making the AI smart enough to deal with real time input. And then the models have to adjust in real time. The whole thing has to change. And, we started these conversations because you asked me, can I predict the future of AI based on my history in the computer business? And I'm doing it right now. That's what I'm talking about.
Yeah. So very interesting. So it didn't actually make it that much better. It made it cooler, a little bit different. There's a few things. I don't remember what the big difference is. But imagine this, if I had actually put like 30 minutes of time into it, which brings up another part of the conversation, which is planning. How much planning has to go in rather than me just prompting it to do something, which is a big thing. And so you got to the part where I wanted to get to, which is Starlink. So, but Starlink is only one piece of that. There's one tangent that I would like to come back to later about what happens when Starlink replaces all ISPs and the protocols themselves are now reliant on the key centralization process of the satellites and what that does. But then also does that, I posted that to Twitter, and one of my followers, he basically said, oh, but that'll be great because then we'll have mesh networks. And the mesh networks will essentially allow the Starlink to connect us line of sight. So I want to go into that. But first, that's one component of the Evernet, is that you have the satellites beaming down internet to us, and it gets high speed and it's like immediate. But the other part of that is the inference. And we've talked about this before, is the inference. When I showed off this thing, this is things going to an API to one of their data centers and crunching a huge amount of numbers so that it can get it back immediately to me. And that immediate thing is still batch processing. It still takes 5 minutes, as we just talked about. So that piece, how does that piece condense?
So you brought up multiple issues at once. So, so physically, the ability to be in real time is one issue.
Yeah.
Right. How intelligent the systems are to deal with that is another issue.
Oh, interesting.
And maybe inference is the right reference point for that. I don't define inference, by the way.
Yeah. So there's two stages. Yeah, there's two stages for, and I actually went on the philosophical inference because they stole the word inference from the philosophy. It's totally different. But so we've got two stages, when very simplified, where we train or when we use an LLM model. One is the training phase, and that's where I worked for Invisible Technologies, helping to do RLHF, a huge amount of training, pre-train, all those different things. It doesn't end there, but you train the model, costs billions of dollars, and then once you have the model up and running in these giant data centers, crunching in these giant numbers, then every time you make a chat call, a call to the API, or if you're doing it locally, you use your local GPU for free, which is a really important part, because if it's local, it's free. If it's API, you have to pay. And so that either of those two things are inference, when it basically you prompt it, and then it goes through this giant neural network and pulls out the relevant parts of all the different things as it's doing its token prediction. So it's like token prediction. What do you think?
So that's not really inference in my mind, but I mean, it's not intelligence. It's not native intelligence. It's still referring back to what exists by using its tokens to predict the next one, or using the LLM to predict the next token. So it's still bound by what is true. True inference, and this is what we're able to do, is we got to process all this stuff and we come up with something completely irrefutable. It's the essence of creativity, actually.
Yeah,
that's something that's really important to me. But so I don't think computers will ever be capable of being creative, because they must use
derivative. You're saying they're derivative. It should be called derivation rather than inference.
Yeah, I mean, it's a step shy of. This is why I'm not totally on board with AGI, artificial general intelligence.
Yeah, interesting.
I don't really see the paths of that. And I see there's the people who really know and are totally geeked, don't agree, right? So if they don't agree, that's probably an indication that nobody really sees the path. Some are making it up. Some are admitting they don't know what's going on. And maybe that's something that can happen in the future, maybe with quantum, and I don't know. It's like the amount of, it's not just a matter of processing power, as we've talked about before, we have this little 1 pound thing in our head that is far more powerful than any computer system, partially because it can derive creative thoughts from confusing mishmash of stuff. So, what was your question?
So we were talking about real time. We were talking about, you answered it. You basically said it's not going to happen. It's probably not going to ever happen. But even the thing we're doing, we shouldn't call it inference. We should call it derivation. And if we actually develop some sort of world model, and this is what Jan LeCun was working on before the old Scale AI CEO. I love how much Facebook is losing because of all the censorship that they did. It tickles me how much they're losing, because I'm so thankful that they are losing, because they should have no legitimacy or authority deriving from anything real to actually lead the AI charge. And they just got rid of Jan LeCun and brought in what's his name, who maybe
Alexander Wang.
Yeah, exactly. It was just like, it was a body shop.
It's like 26 now.
Yeah. And he ran a body shop, so he just got millions and millions of people all over the world to do really shitty data labeling, and nobody likes them. And then Facebook spent billions of dollars on this guy, which is fascinating. Yeah.
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 Still didn't get back to what the question.
So
The real-time system, a true real-time Ethernet system, may not itself lead to superintelligence, whatever you want to call it, but it will be really effing amazing what happens there. It'll be completely transformative. So I totally buy the idea that these systems, these artificially intelligent systems, are transformative. I just don't think that we'll see the Terminator, where it takes over from us, right? Because I think we'll always still be somewhat smarter than anything a computer can do, or a bunch of computers or a whole network. So that's my worldview. So my test of everything is, how useful is it to me now, right? Can it deal with what I have to deal with, right? It can't. It doesn't do that. It doesn't, and maybe that's just an app problem.
It's the fact that you're on,
figured out how to deal with time zones and flights and shit like that.
But it's also because you're on Microsoft Office, so you're in a container that is not getting hooked up well to these LLMs. If you're on Claude,
remarkably, because this is all Microsoft's strategy with Copilot, is that they're offering this agentic future to people that work in big companies. I don't work in a big company, and I regret adopting the Microsoft platform because I'm stuck in it, But I've also got a parallel system going in Google, and even with Google, it's still a stretch. So, and Google and Microsoft and OpenAI, these are all people that are supposed to know how to do this stuff. And they're dealing at such grand ambition level that they're missing kind of the point, which is my fundamental view of the value of all the stuff that they've spent money on so far.
Well, this is interesting because I think if you were to adopt Claude, you could do a lot of the things that you want to do, because Claude now connects with most of the Google accounts. So you could, I have sort of like hesitancy to connect all of them together just because I don't trust either of them or any of them. And I just want to get everything locally as soon as possible, and which is actually, I've made major progress in getting things locally. I now have something called an agentic drop zone, which is the thing that I was showing you, matched with sort of like an automation scheme that I just have something listening inside of a folder, and anytime a audio file gets dropped in that folder, I automatically get it through OpenAI Whisper, but I don't make an API call. It's all done locally using my GPU, because OpenAI made Whisper one of their open source things. And so it's on my computer now. Now I never have to pay for transcription again. I used to pay $60 a month to go use Descript in order to do this. I now save, I don't pay for that anymore. It's all local. And that's my idea. I don't think this will be a mass thing. I think the masses will definitely use APIs for the rest of the time, but I'm very excited about a local future. And I'm probably about 1 to 2 years away from investing in a very heavy duty NVIDIA setup where I have my own GPUs and can basically get everything done inside of my own computer. I wonder if that's real time. That probably won't be real time, because the inference, although probably wrongly named, is probably going to continue to take time on a computer, even with a really good GPU.
So, so part of what you're talking about is, instead of the LLM being remote, you have a different LLM on your device, and it's operating against the system that you already have and on. So you're not paying anything for tokenization and so forth. So it's a parallel system, but it's behind. It's behind the network-based stuff, right? Yeah. So one of the things that's really interesting to me, and because I'm an iPhone user and an Apple person, is I think intelligently, maybe because of the new regime at Apple working on their Siri and artificial intelligence efforts, they've become much more focused on LLMs that exist on the device, and they're working with OpenAI and others to do the remote LLMs, so they don't have to sort of spend the development costs of doing that. And because Apple has so many installed users, they're getting a good deal from OpenAI, et cetera. So, but the core of the intelligence in Apple is going to be the part that sees on your device all your personal information and uses that to deliver value to you, which is precisely consistent with the value that they've always had to users, that they focus more on the user than on the organization, or the architecture.
Interesting.
The broad issues. This is part of why when they announced Apple Intelligence 2 years ago, that kind of missed the boat. And that's because they were trying to do what everybody else was doing, as opposed to doing what they're good at. And so now they're focused on building LLMs that exist on your device and having a device with like M5 chips and a whatever chips. And, they have the embedded processing power on their device to run an LLM that serves you personally. And I think that's really pretty exciting, because they did this stupid boo-boo of announcing the wrong thing at the wrong time. They've been very quiet about it. But if you kind of read about, Meta just scored one of their AI people from Apple. It's actually, Meta's been rating Apple a lot. And it's kind of like Meta's taking the people who are doing the old way out of Apple. And so now Apple's just focused on, this is all me just making.
Yeah. You're doing inference. You're doing.
This is inference, right? Yeah. It's my secret power. I am a local LLM. Yeah. So anyway, so I'm beginning to go like, I skipped the iPhone 17. I still have my 16, which is work just fine. Although I had crazy thoughts about buying a earphone 17 Air because it's so cool. But wait. But the next generation of iPhones, because they keep amping up the processing power on these things, that at the time that they are able to host LLMs on their device, they'll have a device that can do that performatively. And
Brilliant.
And it won't, slow down the device, but suddenly it'll start doing magic.
Okay, that's really interesting. So it's like the phone itself will become the edge device, and I've been checking on this. So the edge device, what do you think about the M5? What are all the things that they're doing with the M5 chip? Well, this could go back into the history of how they integrated all this stuff. Like, what are some other crazy things about the way that Apple integrates all this stuff into so that they can do processing power? Why do you need more processing power on a computer or on a phone?
So that was like 3 different questions with different answers. So
Yeah,
I'll start with the fact that, first of all, Apple, without knowing it, did exactly the right thing by buying Next. It wasn't just getting Steve back, but Avi Tavanian and their hardware people had figured out the ideal architecture going forward. And it was not actually ARM at the time, but those people came with Steve into Apple.
Yeah.
And they took Next OS and the hardware architecture they had in Next and migrated it into the Mac originally. So the Mac now, I'm talking to you through a computer. It's a MacBook Air. I think it's a MacBook Air. Yeah. It's 2 years old and it uses the M2 chip. 2 years later, they introduced the M5. There's no 3 and 4, so they kind of jump shifted.
I have a 4.
You do in a Mac?
I know. No, sorry. Yeah, I got an M2. That's interesting from 2023. Yeah.
Yeah. So the M's are the Mac chips. The A's are the iPhone chips. And so they've been much more focused on the iPhone because, that's the majority of their revenue. And they've been a little slow on the Mac, but they just introduced an M5 based. It's not a MacBook Air, it's a MacBook Pro.
No.
And I just bought one.
Okay, so there is
the Apple store when I was in San Francisco. I was like trying to figure out, and I just bought the M5 MacBook Pro. Hasn't been delivered yet. It's slightly smaller than my computer, but it's way more powerful. I've got 2 terabytes of, RAM, DRAM or whatever we call it, and M5 chip, and so I loaded it, and and I played with it in the store. And the experience now, what we're doing is through the internet, and Riverside's processing all this offline. So that's not really taxing the local computer that much. But where everything it does tax, and this will happen in the iPhone architecture as well, will be running LLMs on the device, right? And that's going to consume a lot. And the same thing you're paying for tokens, or at least OpenAI or whatever is paying for tokens, they're expending a lot of money doing that. Well, you offload it onto the device. If the processing power is there and it operates performatively through all the different pieces of the system, which is exactly what Apple's done by migrating chipsets and architecture on the Mac and then on iPhone, this becomes a whole different thing. And so that is kind of the internet, because we went into, I think the last 2 times ago, we talked about distributed versus centralized computing, but if your edge devices are just as powerful as your network devices, they operate, as long as there's a network in between that can keep up with it. They both operate at speed, at real time, and then the network binds them together. And so this is the Ethernet architecture. So, but you have to do it on the device side as much as you have to do it on the network side. And so most of the AI business is fucking on the network side, right? Who else can do that hardware development? Well, there are people. Samsung can do it. They're still a little weak on the operating system side because they're dependent on Android.
China can do it, or Huawei can do it.
Yeah, China, and actually BYD can do it. And then with a little bit of the computer on 4 wheels, they're people who, I've never been in a BYD. I saw one in Iceland, I think. But you sit in the back seat and you're operating at speed with the internet. The issue is if you're in the driver's seat, but eventually, the car will be the driver. Anyway, so I mean, it's like, this is all the stuff that has to be tied together, but a key component is, and Apple's on it at this point,
is edge computing, but with LLM specifically built for it. So, and you just reminded me of something. I've been doing a deep dive on how much of an advantage Google has over OpenAI versus Claude. And one of their huge advantages is that they have a huge amount of TPUs, which gives them like 20 to 30% savings on what OpenAI and Claude both have to pay for, paying both Amazon. And then there's another weird thing I learned, is that Amazon invested in Claude, in Anthropic. Anthropic has Amazon serving their models, and there's an Israeli company called Annapurna, which Amazon bought for like $3 billion like 7 years ago. They're making it possible for Claude to get all their inference from Amazon servers. So that's an interesting thing. I don't know much beyond this.
There's another little thing in there.
Yeah.
First of all, TPUs are tensor processing units, and
yeah,
Google invented tensor.
Yeah.
So they have a native architecture that they designed and built. So they have been in the hardware business in a way that most people don't understand. Amazon has also done that. So Amazon designed its own ARM-based chips for servers. And so a lot of the competitive strength of AWS, of Amazon Web Services, is that their servers run on their proprietary architecture, much like Apple's runs on their proprietary architecture, although it's ARM-based. And so a lot of people are going, where's Amazon in AI? Well, they're just not telling you about it, right? Because they've got their own proprietary architecture that they've rolled out and their systems. And so, they just had a really good quarterly report. So people are actually going and, oh, Amazon doesn't appear to be out of it. Because AWS itself is growing faster than the rest of Amazon, largely because of their architectural advantages.
Man, it's getting so crazy. So my question then is, so I've got these guys, and I got my Raspberry Pi, and my Raspberry Pi is the central unit, and I'm just going to put these guys everywhere and connect them to the Raspberry Pi and have like a computing thing. I don't know what I'm going to do with that computing, but it's partly just for fuel for this show, so I can ask you questions about everything that's going on. But eventually that Raspberry Pi, maybe in 5 years, will take what Apple figures out how to do proprietary, but then once it's open source, my Raspberry Pi will be strong enough and powerful enough, and the architectures themselves will get good enough so that I can run into my Raspberry Pi. What does that future look like? Like, doesn't that automatically remove the need for a lot of the networking? Because we've been talking about how Cloudflare allows for the networking administrators to kind of win. And right now with the inference and all these proprietary at the edge models, like, yeah, that is really real. But 5 years down the line, when the LLMs get good enough, like, what if there's no thing that replaces an LLM and this is the technology that we get stuck with for a while? Like, what will that world look like when it's just like, it doesn't feel like the normal computing, the normal software thing we're going to have is going to be the way it looks then, right?
So I mentioned the last one before. there's been a dream in the computer business for at least 50 years, the whole time I've been in it. And you don't need to program, that systems are at your beck and call. And it's kind of what you're trying to get at. So is there value in having, a device that's proprietary? Does Apple eventually get sidelined because all devices are so good that they run their local LLMs? And so what's that operating system and what's the network system that's going to be true? This is a possible eventual outcome. However, the kind of companies that can participate in that kind of environment and architecture need to be big tech companies, that they need to have an embedded understanding of computing and networking, that it's very hard to do in a startup, right? Because you have to be able to do everything all at once, everywhere. And this is why people are reacting to big tech. It's like, there's a perception that there's no way to defeat these companies because they're so big and so invested in everything to do with it, the server architecture, the network systems, AI, all of the things that we're talking about. How does a startup get into a place where they can mess with that oligopoly? And that's the big concern people have. Like, we already lost control because these big companies have so much and so deep technology that there's no way you can catch up. I think it's true at some level. It requires one of these companies to screw up. And maybe Meta's the example of that, although they're doing a pretty good job on the glasses. And they still make a lot of money off of Facebook and Instagram, even if I hate using them. And that's just me. And you think they're evil, and I agree with that. But they have people trapped in their systems. So we're a whole nother generation of systems that could unseat Facebook in the social media environment.
So that's a really good point. That gets to the philosophy of the corporation. Why do we have a corporation? There's an economist named Ronald Coase, and Coase talks about coordination costs. And the reason why we have a firm or a corporation is because it's really hard to sell things on the market. Why don't we just have like everybody doing their own business and doing all this different stuff? Well, because it's really hard. It's really hard to go find people to buy your things, really hard to contract with people. So this is why people work for a larger company, because the larger company gives them stability because they already found it. And what you're talking about is like that stability, like, yeah, the tech companies there is no weakness there because they draw the most intelligent people and they're building artificial intelligence. So it's like they become leviathans that can't be brought down, right? Which gets
we fear people have. But, I've been through this business before, is Microsoft relevant or irrelevant? What we've talked about before, that relevance is the key indicator. So IBM is a perfectly profitable company and actually had a good report last quarter, and, but it's irrelevant. Except maybe in AI and maybe quantum computing, but those are over the future. So the relevance factor still makes a difference. It's really hard to see how Apple dies or becomes irrelevant. It's really hard to see how Google becomes irrelevant.
Yep.
It's possible to see how OpenAI might.
Yep.
And Microsoft is just barely relevant at this point because it depends too much on OpenAI, but they know that and they're working on doing their own stuff. So who else is out there? I mean, Amazon clearly is in the game. I love Anduril. I love talking about Anduril because nobody believed that it was possible for a startup company to become a prime contractor to the government. And they basically said they were going to do that from the beginning, and then they proved it out, right? So people actually believing that Anduril can't fail at this point, which is precisely probably when it will have a problem. But so it's possible to do stuff that, or Tesla. I mean, who the hell knew that, a startup company would disrupt the automobile business to such a degree that every one of them announced at some point that they'd be all electric by X year. Yeah. And although that's changed, it's still remarkable that Tesla started that, or SpaceX and blah, blah, blah. So you can still have startup companies that disturb what appear to be pretty stable legacy environments. And that has to be true in big tech. There has to be the potential for someone to come and disrupt the FANG or whatever they are these days. And actually, that it can't be FANG because Facebook became Meta, but the main so it's always possible.
So you mentioned some interesting stuff about OpenAI, and I was curious yesterday to go look at what are the comparable examples of how much money OpenAI is losing versus something like Amazon, because I had remembered in the Amazon, they used to complain about in the early 2000s, Amazon didn't make enough money. They were losing money constantly. But then I looked at the numbers and I was like, oh, okay, that's not anything close to what. And then they said the same thing about Facebook. And then I looked at Facebook and it's like, oh, it's also not the same thing because Facebook didn't spend, it's the scale of the money. The money that OpenAI is spending is the $27 billion. And the closest thing is WeWork. Well, it all depends on what they mean by unit economics, right? Yeah. So what is the unit economics of OpenAI? It's tokens, right? That's the only...
we don't really know. They can't really define it. Even OpenAI can't define it.
Yeah.
Yeah, so they... On an operating basis, OpenAI is making money.
Yeah, interesting.
Right? Their problem is the capital expenditure of building out these server farms.
Yeah,
and the models. But on a unit economic basis, the tokens on an operating basis, they're making money. That's part of how they get raising so much money.
The future cost. They're investing in the future cost. Interesting.
Right. At some point, it stabilizes and their revenue keeps growing and their costs don't. Which is kind of classic bubble economics. So it's fine if it works. And, Uber is the interesting one there because people had written Uber off. It's like Travis Kalanick had screwed it up and this guy named Derek Kashahowski took it over. And, but because they had an operating guy take it over and Kalanick had done all the kind of core work of establishing it internationally and having operations everywhere. Derek just kind of operated it out, and now it's an intensely profitable operation. Nobody remembers the old days. In Uber, WeWork is different. It actually went bankrupt, and it's a mirror shadow of its former self.
So let's zero in for the last 10 minutes or so. The unit economics on OpenAI. How do you even how would they? We don't know what it is because OpenAI is a closed source thing, which now became proprietary. They finalized the deal with Microsoft. I'm going to do a deep dive next week so how do you figure out what unit economics are at play in any of the large businesses? Because it all seems very fuzzy, right? It's well, they serve tokens, they do inference, but they do R&D and they do investing in data centers. So there's all these pieces. How do you bring it all into one holistic analysis?
I can't. Just admit it right up front.
Yeah.
And you could say that tokenization is the unit economics that they charge, 2 cents per token.
Yeah, interesting.
And they do billions of tokens. It's a little bit like Google's original business search. It's like, you pay pennies for any one search, but they do so many searches it becomes serious. But there's a mixed model in the OpenAI companies. Some of it is enterprise licensing, and some of it is individual subscriptions at $20 or $10 a month. And in both OpenAI and Anthropic, the revenues are sort of equivalent on either side, although I've seen press recently that people think Anthropic is more defendable because it's more of the enterprise. They're charging for API access, which is different than tokens. So their unit economics is around every time there's an API call.
Interesting.
And so, I can't really tell you because they're all private companies, right?
Yeah.
Except Microsoft and Apple and companies like that, or Google.
Yeah.
And it's really hard to figure out what the ultimate unit economics are.
Yeah.
Is it a subscription business where it's all about, how you renew subscribers and so forth, or is it a product business? And it's like, it's crazy time where it's really hard to figure out exactly how it's going to settle out, much like 1999 and the original internet.
Yeah, interesting.
people were making all kinds of crazy stuff like Webvan. But Webvan actually predicted accurately because Amazon runs a delivery business, and their logistics are so intense from acquiring the product and storing it and then shipping it out, that they've managed to figure out how to do the economics that Webvan didn't even really take a shot at. But so these all the ideas that people have can become healthy, growing businesses, but only if they're operated well and executed well.
Oh man. Okay. Next time we can talk about operation and executed well, and who are the best operators in history from the 1980s, 1990s, and 2000s. Actually, next time we're going to talk to the Bushnells again. So for the last 5 minutes, I want to make sure that I understand what a mesh network is. What is a mesh network? Have you ever interacted with them? Have you ever invested in them? What do you know about them?
Starlink is a mesh network. So a mesh network, that all the computers in the network talk directly to each other.
Peer to peer.
No,
peer to peer. Well,
as in there is that's at an architectural level that they have the same capabilities and communicate with each other. But a mesh network is any one node on the network can talk to any other node on the network. It's not one-to-one. It's like one-to-many, but all of the ones can communicate to all of the many. So there's a mesh, and that's why it got that name.
Okay, got it.
And it's a poorly understood concept because it didn't really work when people came up with it, as always. Now you can do it, and the fact that you can do it actually is less important. So the Starlink satellites up there,
they all talk to
each other.
Yeah. Okay.
So there's routing between the satellites to optimize the back and forth from Earth and into the satellite network. So it's but it doesn't. That was a core part of the architecture that SpaceX made when they did the Starlink network. The question is, is Amazon's Project Kuiper capable of doing the same thing? I think they're up to 40 or 50 satellites now.
Okay.
They anticipate correctly that this would be an issue once they have thousands. The Chinese are building their own, and SpaceX is building one for the U.S. that's separate from Starlink. I can't remember what the name is, but so they're and Europe wants to build one too. Everybody wants to have their Starlink. So and Starlink is the model, and everybody's looking at it and going, "How the hell do you launch 9,000 satellites in 3 years?" And so that eventually there will be multiple high performance, low Earth orbit satellite networks, and it gets kind of mind boggling. Okay, well, Starlink has 60% of the satellites that are in low Earth orbit right now. But what if 5 other networks have satellites? You're all whoa! It's like we're talking instead of 10,000 satellites, we're talking 100,000, and you have 100,000 circling in the same basic.
Is there enough space up there for that?
Yes, it's infinite.
It's infinite.
Right? So you said lower satellites. Yeah, low Earth orbit is a range, and you can be anywhere in that range. The closer to Earth you are, the better the signal. But the closer to Earth you are, the faster the satellites degrade and fall out of the network.
Oh, interesting.
And Starlink has done this. They've launched 12,000 satellites, but 3,000 have become non-functional.
Wow.
And the requirement in space is that you plan for obsolescence, so that you're not just going to leave a bunch of junk up there. Problem is, there's already a bunch of junk up there. It's like you to get rid of the junk that's already there. It's one of the leading edge problems in space management.
What an interesting time. Okay, well, yeah, great episode again, and see you next week with the Bushnells.